This is the first course in a series of probably 20 or so I gave, really looking at getting started in manufacturing and how do you pick a great factory. And initially I dove in like pros and cons of big factories, small factories. But when I took a step back, I was like, well, you should probably think about where you want to build. Is it domestically? Is it in the US? Is it in China? Is it in Mexico? And then based on that decision, then you can kind of narrow down and go through the process of picking the best factory. So I figured it's a good place to get rolling just to look at 5 examples and sort of brainstorm where we might want to build them. So we've got the Roomba, Goop in a bottle, a yoga chair from Olin, which is pretty cool, a pair of jeans, and then a military robot. And just kind of walking through it. So this is a Roomba, it's a high volume consumer product. Sort of, when we think about that, the first thing that pops out is it's probably pretty labor intensive. And most people would think of China as a great low cost labor base, which is definitely one of the selling points. It's a lot more interesting than that, but sort of off the bat, it's like, all right, maybe that one would make sense in China. So that one's kind of an easy one. This one's a little bit more complex. So it's super high volume. You've got a blow molded bottle with goop inside it. And on first pass, high volume, maybe it makes sense to do it overseas. But as you think about it a little bit more, and if you go in your shower and look, you'll see actually all of them are made in the US because it's totally automated. So labor is not a factor at all. You just want to minimize the shipping cost. And also controlling the quality. There's all sorts of great stories about how the quality drifts overseas, particularly for things like this. In fact, at the end of this, I have some references, and one of them is poorly made in China, and it has all sorts of like horror stories of things going terribly sideways. This one is a yoga chair, so sort of yay big, that one of the first classes of Olin came up with. And that one's kind of an interesting one in that you've got a bunch of injection molded parts and then some cut and sew. So for this, it could actually go either way. For a low volume, you might want to build it domestically. For high volume, then potentially thinking about Asia due to the labor. For clothing, usually you're looking for the highest margins or lowest cost, and they're pretty labor intensive. So for those, actually, China is too expensive. You might want to go to Bangladesh or Vietnam or someplace like that. And then for a military robot, just due to ITAR, it's pretty obvious that's going to end up in the US. But it's super important before you start figuring out, what factory should I pick? Where should my factory be located? And what I've done here is basically broken it down into 2 main categories. One is China, and then the other is the US. I had mentioned in the beginning thinking about domestic, and that's, suppose you were based in the UK, then you'd really want to consider, say, the UK versus China or the UK versus Mexico, because there's a lot of advantages, as we'll talk about, to having your factory right next to you. But anyhow, we'll start with China. Typically, you think if your product is cost sensitive, or we use the word COGS, cost of goods sold, then it may make sense. For military products, it's not like, who cares about the cost? It's not the main objective. And I should always say that in our world, we think of cost, quality, and schedule, and trying to figure out the balance of automating, or of optimizing. So
Pick 2.
Yeah, you get to pick 2, that's right. Although in consumer electronics, you always want to control all 3, but you can't. So in general, if you think it may be cost sensitive, China may make sense. As we were just talking about, labor is a key component, and labor and volume. The rough rule of thumb we have is if you want to build more than 10,000 units, then China makes sense. If you want to build less than that, then you look at other manufacturing bases. And the reason for that is that the factories make their money by charging a percentage of the cost of goods sold. So let's say your product costs $1. The factory may charge 15% of that. So if you're only building 10 units, they're not going to make any money, and it's not interesting to them at all. But if you're building, hundreds of thousands of units, then it definitely adds up, and it makes business sense for them.
And that 10,000, is that annual volume?
That's what we look at is at least the first run. And it depends on the factory, which we'll get into as we talk about picking a factory, on the size of the factory. Some of the bigger ones have requirements that they want to see $1 million of revenue the first year, then $2 million the next year, and so on. And if you don't fit that, then it's not a good fit. For many of the smaller ones, say like a local Chinese owned one, then it's more the volume and they can work at smaller runs. Another reason we look at this is the idea of minimum order quantity, or MOQ, And the example I'll use here is if you want to buy 5 beers for some reason, it's probably cheaper to buy a 6-pack, and then of course you drink the other one anyhow, than buying 5 individual beers. In the same sense, when you buy components for an SMT machine, which it does the pick and place to populate your boards, you typically will buy those in MOQs of 5,000 units. So if you want to build 3,000, you're left with 2,000 overage, and you lose all your cost advantage. And we're definitely seeing that number go up. And there's certainly a trend in China these days towards much more automation. But it did start out, pretty simple arbor presses, screw guns. Sometimes we'd see them do a cowboy style with one in each hand, so you can go twice as fast. But pretty simple tasks. And those are super handy in that it's really easy to reconfigure. Like if you think about what you get, right now we're seeing, say, the labor rate's about $4 an hour across many of the factories we work with. If you think of hiring like 10 or 8 fingers and 2 thumbs plus a full vision system for $4 an hour, like that's insane what we can do. Like, I can do this all day long, whereas if I think, based on our heritage at iRobot, what it would take to design a robot to be able to do that, depending on how the beer can's positioned or what the light is or where I'm standing, much, much more challenging. And then if I change the project, so I'm not using a beer can, I'm using a thing of orange juice, that's a lot of work to reprogram the robot. But the capability you get from a human for that rate is just insane. So it's good for that sort of growing volume. One of the key things, and this is a hard-earned lesson that we got from iRobot, is that you want to use existing technology. So when we were designing the Scuba, we were doing this tank, which was a mix. It was basically a 2-section tank, a clean fluid and a dirty fluid. And we decided we were going to use a laser welder because lasers are cool. It's like, wow, this is an awesome thing to do. So we designed this really complex part, worked with a great company in New York, which is, in the factory we were working, there wasn't any laser welders. So we worked with them to put together this laser welder, which is like a $500,000 machine. And then I think we flew it over to China, which cost a huge amount of money. It plunked down, and then we started running the thing, and it didn't work at all. Like, we just couldn't melt the plastic. You're like, this is seriously not good. And we worked at it for days and days, and during this time, we're running totally behind schedule because everything has to be laser welded. And eventually we ended up having one of the engineers from the company that built it get on the plane, fly over and look at it. And what we realized is it was an ecosystem of 8 different electrical components, all running on US voltage that had been converted to Chinese voltage because they're different, except they forgot to convert one of them. So it took like an insane amount of money and time to figure this thing out, totally backed up the schedule. Eventually we got it working, but we realized if that machine ever broke, and we were kind of dependent on this as we were getting ready to go public, the whole line would shut down and we're dead in the water. So we ended up buying hundreds of thousands of dollars of spare parts, of spare laser heads, and just everything to have it in stock, so just to ensure that this machine didn't break. The alternate way to design this product would have been what we call glue and screw, which is, maybe it's a CNC glue application device and a bunch of screws. Super robust, not the sexiest thing in the world, but man, it's not going to break. Anybody can fix it. Yeah. So really sticking with stuff that already exists in your factory. This is just a picture of an pretty big injection molding machine. Like, China has that down cold. So you want to stay with what you know. You also, given the fact that China is just so unbelievably far away, it's halfway around the world, that you want to have a product that is robust to a longer supply chain. So if you need to be able to fulfill an order, like if you order something and need it the next day, it's going to be very difficult to do that from China, or very expensive. Whereas typically the shipping time is 4 to 5 weeks sitting on the water. And it's relatively inexpensive for small products. In a 40-foot HQ container, you'll fit about 5,000 Roombas. It's a $5,000 to move the can, so about $1 a Roomba. So not the end of the world, but it does take 5 weeks. And what we also find in China is there's just amazing domain knowledge on design for manufacturing, assembly, molding, and things like this. And you can get it for a remarkably cost-effective price. The great thing about having the factory do this work up front is, by definition, they have to be able to build it. They can't point the finger and say, well, it just wasn't done right, we can't build this. There's a lot of accountability that goes with it. So for this reason, we often advise our clients not to put in drafts or rounds on their molded parts, but just get it straight walls and then work with a great factory that can do that, because it's much more cost effective.
It's a big deal.
Yeah, it's a huge deal, and it keeps the model so much simpler because once you've tilted everything,
Yeah.
how do you measure the distance across it? Like, and they get bigger, and they tend to become or more likely to become corrupt. And then, IP is something to consider everywhere, not just in China, but certainly you'd want a robust strategy to how to protect it. So if you're only building a mechanical part, no software, no electronics, that's much, much harder to protect because anybody can, with a laser scanner, can go and reverse engineer it. Most of the stuff we do is good electrical software and mechanical, and you can definitely put together a good strategy to protect that. But you'd want to think about that carefully. So those are sort of the things to consider. Drawbacks, as we've talked about, and it's pretty obvious, it's really far away. So it's much more difficult due to the time zone and the language just to pick up the phone and say, hey, can you move this hole from here to here, or can you do that? The language is a lot more challenging to learn, and although it's an amazing language, and it's certainly worth the effort. Whereas China, as we were talking about before, was selected due to the low-cost labor base. There's a lot more reasons to be really interested in it than that, although it is a factor. And the wages continue to go up every year. We're seeing roughly 20% year-on-year growth. Now, usually the labor is a small part of the BOM, so it hasn't had a huge impact. But it is an exponential trend, so something you have to keep track of. And then also the currency is going up. It was pegged until, I think, 2005 at 828. And now it's pegged to a basket of currencies. So who knows what that will do? I'm no economist, but it seems like it's been undervalued. So as that goes up, it makes manufacturing in China less advantageous. And these are things we have no control over, so you sign up for it if you go to China. So that's sort of a quick look at China. We'll take a look at the US. So obviously, if you're doing super low volume, it's much easier to be at home, where you can just drive and talk to somebody in the same language. Strangely, if you're doing super high volume, it's easier to be in the US because you can invest in the robots, which, for cars, given the insane amount of volume, it's worth the overhead and the setup cost to go ahead and automate and invest in that infrastructure. So it's kind of on either ends. And then if you're very sensitive to the shipping cost, so let's say you're building a huge refrigerator, you don't want to incur the cost of moving that from China to the US. You might think of Mexico as it's closer, or just building it domestically. GE's doing some pretty cool stuff down in Louisville, building domestically. IP may be easier to protect. Again, it's something you want to think about no matter where you build. And then this is a good spot for the laser welder if you're doing crazy things like that and really, really pushing the edge. And then finally, as we talked about, military or anything that's ITAR, you've got to build in the US. So that's just sort of meant to be like a real high level thinking about where do you want to start building. What we'll focus here on is how do you actually pick a great factory. And we call this the request for quote or RFQ process. So this is a quick overview of how we look at it at Dragon and how we go about it. One is you've got to start with some factories. And you could look at Alibaba, but we definitely don't recommend that because it's totally embedded and you never know what you're going to get. The best thing to do is to talk to people in your network that have built product before and just ask them, hey, what factories did you use? What was your experience? And at Dragon, we're always happy to help, give you a starting list and debate the pros and cons of each one. Ideally, you'll get about 5 to 10 CMs or contract manufacturers. And you do want to have a spread between them. So, and we'll go into more detail in a sec, but maybe some Hong Kong-owned, Taiwanese-owned, local Chinese-owned, US-owned, big ones, little ones, public ones, private ones, so that you do have some different levers to look at. It's not all the same thing. And from there, ideally, as you sort of whittle down the list, you want to end up with 3 to 5 factories that are a good fit. The reason we pick that number is that with 3 you get voting. So with 2 I don't know who my outlier is, but if I have 3 I can say, oh, this one's higher, this one's low. If you do, the top end is 5, and the reason we don't go more than that is A, you're not being efficient. You're spreading your IP and your effort around more than you need to. 5 gives you the ability that if one no bids it or doesn't want to participate, you still have the right to you can still get voting out of it. So you go and pick your factories, You'll generate an RFQ package, which I'll walk you through. The next step is super important. You actually want to have feet on the ground and go visit the factory, no matter where it is, US, China, Mexico, it doesn't matter. But you want to look the people in the eyes that are building your product, and everything is relationship-based. Start to get to know them. You'll send over the RFQ package. They'll look at it. While you're visiting, you can answer any questions back and forth. And then they'll eventually give you their analysis of it. So this is what we think the bill of materials is, the schedule, and so on. They'll look at it in a sec, analyze the results, figure out what the big levers are. So you don't want to go into the minutia of debating, say, the cost of a tenth of a penny resistor. Who cares? But focus on the bigger things like the margins and so on that are going to have a bigger impact and are easier to negotiate before you've signed the contract than after. Once you've starting to narrow it down, then it's a really good idea to talk to the customers of the factory just to get their relationship, because things do change after you've signed on the dotted line, and you want to make sure that the factory, still is a good one. And then after you've got that, you should be able to pick a winner. Spend some time letting the ones that weren't awarded the project know that they did. You really appreciate their effort, because often the factories will put a huge amount of effort into it, and you want to leave them on good terms. What likely will happen if all goes well is your volume will take off like crazy, and you want to add additional suppliers. So being able to go back to them and say, hey, we didn't award it to you on the first one, but we'd like you to participate as we expand is super important. And it's a small world, so you want to leave everything on good terms. Here's a snapshot of the three parts of the RFQ. The first one is typically a Word document, and the way we look at factories is they're a lot like VCs or investors. They've got limited resources in terms of money, people, and effort, and they want to back companies that are going to jump into very high volume, so they've got to be super high potential. You always want to be very truthful in terms of the information you provide, but you also want to get them excited about your business and show them the potential that, wow, this thing really could be the next iRobot and take off like crazy. So we spend a lot of time talking about the team, management bios, if they're serial entrepreneurs or what else have they done, so that they're uniquely situated to make their company a success. We talk about the product, what's done, what's not done, what we're looking for in a factory, and how they can help. So that's on the first Word document. And we find ours usually are 20 to 30 pages, so it's pretty thorough, so they have a good picture of what you're trying to do. It's always a balance of, you don't want to tell them how to build the thing, but you have to give them enough information to get excited. So that's kind of the art of it. The second one is a bill of materials, which is basically the ingredients to go build your product. And here it's a balance, again, of not giving too much info, but providing enough to get an accurate quote. And there's a couple of techniques here. One is you want to provide it in a fill-in-the-blanks format, because if you let them all provide their own bill of materials, it's impossible to compare apples to apples. They're all going to break it down differently, and it's really difficult to tease it out. Whereas if you spend the time to basically get it ready for them, it's much easier to do your apples-to-apples analysis at the end. You want to get it as transparent and formula-driven as possible. So if we were building, say, a pebble, it's useless to me to know a cost. Let's pick an outrageous number, $500. I don't know where the money's flowing. What I'd want to do is know how much does each individual piece of plastic cost, how much do the screws cost, how much is the labor, how much is the deco, everything down to the smallest amount, and have it all formula driven. So that I can do an experiment and say, well, if I make it out of polycarbonate instead of ABS, what impact is that on the price? Whereas if I just got, it's a $500 watch, which I'm making an artificially high number, it doesn't tell me anything useful. So break it down, and we usually bring it to what's called X Factory, which is when the product's sitting on a loading dock. You could also do it landed in the US or any other number of spots along the way, but that makes it really easy to compare. And it should all be fill in the blanks. Third part is a schedule, and it's a standard Gantt chart with the durations between the major milestones. So those are the three parts of the RFQ package. These are some items to look at as you visit the factory. And I won't go over all of them, but a few is everything is relationship based. So really meeting the team, getting access to the engineering team and the management team, and making sure that they're, as you look in their eyes, that they're really excited about what you're doing and ready to be a long-term partner for you. Always looking to make sure it's a safe workspace, the workers are well taken care of and are treated ethically is super important. One, it's the right thing to do. And then two, from a business standpoint, the Chinese government will absolutely shut down a factory that's not safe. And if they shut down your factory, you're out of luck. So it's a massive disruption to your supply chain. And you don't want to be in the New York Times in the wrong way. So it's important to look at that really critically. A few other things to look at, are they financially stable? So when you're running manufacturing, you have to buy a lot of raw goods and components up front, which costs money. Do they have the working capital to afford that? Or are they going to be short and that's going to prevent you from growing as quickly as you want to? Are they public or private? In China they call it listed, and that might impact, are they managing to the quarters and are they playing games, or if they're private it doesn't matter, but they may not have as much capital.
How open are they to sharing their financial situation?
They'll share what's called their turnover or their annual revenue, and that's a good gauge of how big they are. They'll probably never share anything in the bottom of the spreadsheet. It's only the top line stuff. And then if they're public, of course, you can get more info. We typically work with a blend of both public and private, usually Hong Kong or Taiwanese owned, sometimes for simpler things, local Chinese owned, where if you find a great factory, you can get amazing results for very cost competitive prices. But you do have to, usually they don't speak English, so you have to know how to handle it. One we always like to look at is, or I should say we take very seriously, is their IP. So if they give you the tour and say, oh, we don't really show anybody else this, but here, take a look behind this curtain and check out this cool stuff, because they're obviously trying to get your business and they know it, but if they do it for you, whenever you're running a line, they're going to show the next guy what you're working on. So that's an instant disqualification. And then, as I mentioned before, just having access to the upper management. So typically, you'll probably be a smaller customer coming into a big factory, and there's going to be a time where you want to pick up the phone because you've got a schedule crunch. Whoever the factory boss is, hey, I need help. I need to get on this molding machine. Can we work on the schedule to make that happen? If you don't even know who the boss is or don't have their phone number, it's probably not. You're looking at too big a factory. Looking at we call it the A to A or apples to apples decision matrix. These are the big parameters you want to look at. So one is the material cost. How much stuff is in the BOM and what does that cost? That's easy to look across the different factories. Two, what is the labor rate, both in the hourly and then the projected labor cost for building your product? And that's good because you can always negotiate that down. Third one is the margins, and we usually break it into three margins. The standard margin, which is just a percentage of applied to everything. The special margin, which would be for components, say more than some threshold, like $1. Because if I have a $25 GSM module, there's no way I want to pay 15% on that, because it's the same amount of effort to place that on the board as it is to place a resistor. So I negotiate everything over a certain threshold. I'm going to pay you less. I'm going to pay you 8% instead of 15%. So comparing that, and then a consigned good would often be like a processor that I buy from somebody else and then I give to the factory. But because I'm doing all that work, there's no way I want to pay the factory full price for that. So breaking those down. And then when you look at BOM, it typically follows Pareto distribution that 80% of the cost is driven by 20% of the components. So like we're saying, don't bother on the 1/10 of a penny resistor, but focus on the processor, the battery, that display the big things. And this is where voting is really helpful, that you can look and see who the outlier is, and then use the other ones to leverage them down. What are the fixed costs which are outside of the BOM? So tooling, fixtures, non-reoccurring engineering. You want to be able to compare that. How long does it take them to get it done? And again, it's not just the start and end date, but how long is the tooling? Usually we look at like 6 to 8 weeks for that. How long to engineering pilot one, and so on. And then the fit criteria is what you've got from actually going and visiting the factory. Do you like the management? Is there good chemistry? So that's basically just an overview of how we go about picking factories. These are 3 books that are always a good read. The first one is by a Wall Street Journal reporter who was really interested in the life of a factory worker, and even more than that, like both the big picture and their day-to-day stuff. And China's got the biggest migrant workforce in the world. Like many of the workers come from the north and go to the south. And it's actually it's a really fascinating topic, which I won't get into here, but I highly recommend that. Poorly Made in China is more of a humorous look, and it does talk about trying to build shampoo in China and how the formula drifts all over the place. So you get a chuckle out of that. And then Mr. China is a real old school one from probably around 2000, well before Chinese manufacturing. Like it was back when you were doing it, totally different experience and what that looked like.